But as of this time, I am going to include the fourth state of matter. Let me go back to my question a while ago for those that wish to answer. You can answer it in the chat box. What is the fifth and the sixth state of matter? The fourth state of matter, the fourth of it is plasma. And the first three are solid, liquid, and gas. So in this discussion, I'm going to include the fourth state of matter, which is plasma, the one that you mostly see in the northern lights, aurora borealis and aurora australis, the northern lights and the southern lights. You can also see plasma in a lightning strike. And if you are going to raise the temperature by 10,000 degrees Celsius, the one that is near to closest to the temperature of the sun, then that is also called plasma class. So the states of matter is based upon the arrangement of the particles and upon the energy of these particles between the electromagnetic attraction between these particles class. Um, Say the kinetic matter theory states that matter is there's also this thing called the law of matter, which in matter is neither created nor destroyed. It's just simply transformed from one matter to another, or from one state to another, and that is now solid, liquid, and gas. And then the fourth one is plasma. The one in the science fair last year was real plasma. Mhm. The 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 ball, the lightning ball with the electric representation, that's a plasma ball, yes. So if you happen to have that in the science fair, then you already saw the fourth state of matter, which is plasma. Matter is made of particles. Particles are made of atoms, and atoms are the basic composition of an element. So that's the structure from the smallest minute substance to the bigger one. We have atoms, molecules, then element, compound, organelles, cell, tissue, organ system, and then the complex human being. No? So that's the arrangement from the simplest down to the most complex. Talking about the kinds of matter or the states of matter, let's talk about the first one, which is a solid. Solids have particles that are tightly packed, vibrating about their fixed position. Solids have a definite shape and a definite volume. And the attraction between the particles of solid are strong since they are closely connected to one another. If you refer that to your module class, you have the table, the representation of the representation of this is arranged in the table. Some structures of solids are represented in lattice form, or some of them are represented in just like in carbon, wherein they have they are not in a crystalline structure, rather they are in a what's that other term for non-crystalline structure? The one in your module. We have here the forgot the other term there. Here, the amorphous structure. Crystalline solids have the tightly ordered arrangement, whereas the amorphous structure are those that can be easily broken down, just like a carbon or a charcoal. These are the amorphous solids. Crystalline solids have a well-defined arrangement of particles of solid. That's crystalline solid. So we have here uh, the first state of matter, which is for a while. There's something there. Wait. So again, we have here solid, the first state of matter, which is having the so-called arrangement of elements or molecules or atoms rather in a definite shape, and the constant vibration of these atoms will generate the heat. No, you can show the heat generation by conducting a short experiment on yours in your hands. You try to rub the two solids in your hand, which is your skin, and it will generate that heat coming from the rubbing of your two hands, and that is known as the and that action you're doing right now is the act of friction, no? Generating heat through friction. For liquids, their particles are not so far, not so close as well. The atoms of solids are sliding past each other. That's one of the indicators of how the particles of liquid slide past each other as its property known as fluid. Do we have that as or viscosity? Do we have that as a property of liquids in your module? Why the term fluid comes out when we talk about liquids class is probably because the atoms are freely flowing from one another or sliding past each other. You notice that when you're going to pour a liquid from a certain container, the motion of the particles just flow from one point to another. No? Liquids have an indefinite shape, but it does have a definite volume. Indefinite shape is because liquids will just simply follow the shape of its container. So they don't have a definite shape. If the container is shaped in a in a sphere, uh, the shape of that solid is spherical, then in liquid takes the spherical shape of the container. If the shape of the container where you place the liquid is cylindrical, then the shape of that liquid now is also cylindrical. Thus, liquids have an indefinite shape, but they do have a definite volume. You can find the volume of a certain liquid with the help as well of a container. Whereas when you talk about gas class, the particles of gas are very far from each other and they are freely moving. Gases have also an indefinite shape, and the a difference between liquids, gases have an indefinite volume. You cannot quantify it easily with respect to solids and liquids because in liquids you can just measure it using a weighing scale or a certain measuring cup to determine the volume. You can also use formulas to find the volume of a solid, but for a gas, you cannot just simply find it that easily. So therefore, you have the shape and the volume of gas to be indefinite. The representation, or rather the tabular representation of these properties of solid, liquid, and gas is found in your module class. We have here. Gases have no definite shape and volume. Gases diffuses from higher concentration to an area of low concentration. They can be compressed, and they exert greater pressure compared to the solids and liquids. However, for liquids, they have a definite shape, but they don't have, rather, they have a definite volume, but they don't have a definite shape, as in this part. They flow continuously and also they diffuse from greater concentration to an area of lesser concentration. One of the diffusion happens in a cell where water flows from a higher concentration to an area of lower concentration through osmosis. So that is liquid. Water is liquid. And then they are nearly incompressible. But at some point, they can be compressed. For example, if you place them in a certain container, they can be slightly compressed. But for solids, they cannot be compressed. An example of it is a wood. With a strong mechanical force, you can compress a wood. But with your own hands, you cannot compress it, unless you are a Superman that can break even or can compress even steel. It is because the atoms or the molecules of solid are tightly packed with each other with no space at all. They have a definite shape and volume, and they do not flow. Probably, you can compress a solid if the molecules are having holes or they have such an amorphous structure. For example, is a sponge. They have holes in it that is filled with air, so you can compress that sponge. But other than that, solids are incompressible. With arrangement of particles, gases are very far from each other. Liquids just simply slide past each other, but for solids, they're closely packed with one another. They're closely packed to each other. Forces between particles, there's no force that is acted on the atoms for gases, but there's a very strong attractive force of the particles between a solid. And lastly, for movement of particles, the gases move quickly. Liquids slide past each other. That's like what I said a while ago. But for solids, they just vibrate with one another because the motion cannot be created since the particles are compacted with each other. So they just vibrate with one another. Uh, So here are the comparison of the properties of solid, liquid, and gas. And then what follows below are the explanations of these properties. No, in the presentation that I have, there is no explanation whatsoever. It's just explained in your module class, like what makes it no definite shape and volume, what is diffusion on another end to gases and to liquids, and what happens to um, what is surface tension and the likes. By the way, surface tension class is the one used by some experiments to place a needle on top of water. I had this before in my science race or ACAD race, where one of the stations was allowing the needle to stay on top of uh, a water without letting it fall on the water. Have you tried ACAD race before, way back when you're still grade 7? Uh, so there was way 2 3 years ago when I had that activity that the needle should stay on top of the water. So there's a slow placing of the needle on top of the water to have that surface of the maximum surface area of that needle to be attached to the top of the water, so that it won't fall down. Then the reason behind that is there's tension on the surface of water as the molecules are not being distorted by the molecules of the solid. That's the mechanism as well used by water striders to float on water, and also from the Jesus lizard. You're familiar with the Jesus lizard? It's a lizard that walks on top of the water, but it's actually not walking. It's like the normal walking. They are they just stop in a fast manner so that they can run on top of a water. And the idea there is because of the surface tension. Capillary action class, on the other hand, is the adhesive and the cohesive forces on the particles of water. Cohesive forces, you can see that in a certain experiment when you are you familiar with the slow mo bros in YouTube? They made experiments of capillarity action on water as they put water in a certain balloon, and then they will fire an arrow to pop the balloon. But after popping the said balloon, the shape of water is still spherical as the previous shape of the balloon because of the capillarity action, the cohesive forces that lies within the said molecules of water. But eventually, they will just simply flow because of the absence of the said containers. That's also one reason why we can fill the cup of water with a certain meniscus on top of it before the water will spill in the glass. There's a cohesive attraction force of the water molecules. But if you are going to consider a certain test tube, have you tried it in a test tube? There's also this what we call lower meniscus in a test tube. The lower meniscus right now is the adhesive force that lies with the molecules of water to the container. The water molecules sticks to the container, thus creating a lower meniscus. No? Meniscus, by the way, class, is the convex or the concave structure on the column of a liquid. Upper meniscus is the result of the cohesive force, while lower meniscus is the result of the adhesive force. And the adhesive force is the ability of water molecules to stick to the walls of the container to where they are being placed. Uh, the next part in the frame here, class, is the different phase changes between the three states of matter, starting off with melting and freezing. Melting is the phase change of matter from solid to liquid. An example of melting is a solid ice to be melted into a liquid form. That is melting. While the opposite of melting is freezing. The change phase of liquid turned to solid. If you freeze water below at 0 degrees Celsius, then water freezes. It will become a solid ice. Okay, so that is freezing and melting. We also have vaporization, the change of liquid to gas, condensation, gas to liquid, and sublimation, solid to gas. You can see um, the graphical representation of the phase change under this table class. This picture here. So, from gas to liquid, the arrow here is this one. So you have the phase change known as condensation. The change of gas to liquid is condensation, while the change of liquid to gas is vaporization, also known as evaporation. Okay? But the general term there is vaporization. If we have gas to solid, the term there is deposition. It might not be found in the PowerPoint a while ago, but that phase change of gas to solid is deposition. A good example there is um, the freezing of snow. No, from vapor it turned into solid snowflakes. So that is deposition. And from solid to gas is sublimation. A good example there is a mothball, a solid mothballs that will just simply turn into a vapor after a couple of hours or days if it will be placed in a certain area in your house. That is the one that will kill some cockroaches or rats or repel roaches and rats. And then the phase change from solid to liquid is melting, and from liquid to solid is freezing. So these are the 6 phase changes of the 3 states of matter, which will be the basis of how you're going to answer activity 1. So as of now, I think you can answer activity 1. How will you answer it? Refer it to the table here or read the module because there's also an explanation here from your module class. Phase change is simply changing the physical appearance of the state of that said matter. Because if you're going to change now the chemical composition of matter, then that is already chemical change. If you burn paper, that is already chemical change. But if you just simply tear a paper into 2 pieces, that is just simply phase change. Okay. Plasma, on the other hand, class, we have here some examples of plasma. If you are going to heat, if you raise the temperature to from 1000 to 1 billion degrees Celsius, then you're just simply changing gas to plasma. No? The fourth state of matter is plasma class, and plasma is an ionized gas. These gases occurs in mostly in the ionosphere, and it could occur through a display of light known as the aurora borealis, which is the northern lights, and aurora australis is the southern lights. It's somewhere in the south pole. Plasma is a very good conductor of electricity, and you notice the flow of electricity there in the science experiment way back last 2019. Was it 2019 or 2020? January 2020, where you have that ball of plasma. Then there's an electric field that flows within it. If you notice as well, there's a reaction with it to your hair. Did your hair raise on that time that you touched that? Actually, your hair will raise that. I will raise during that time. Plasmas, like gases, have an indefinite shape and indefinite volume class, and at the same time, plasma is a common state of matter. They You can associate plasma as a portion of the sun. The solar radiation is filled with plasma. So this is the four states of matter in its graphical representation, from solid to the tightly packed structure, for liquid with a closely structure, for gases which are quite far from each other, and for plasma is made of ions, positive and negative charges. Yeah. Some plasmas occurs in flames, in lightnings, and in the northern lights. This is the northern lights that I mean. Aurora borealis. This is aurora borealis. And these northern lights occurs in the ionosphere. Okay, this is found in the ionosphere. When the solar rays hits the ions in the thermosphere, comes the play of lights, which is the aurora borealis or the northern lights. The southern lights is the aurora australis. The term there is. That is the southern lights, aurora australis. The northern lights is the aurora borealis. Northern lights borealis, southern lights australis. The clue there is Australia is located in the southern part of the no? southern continent, Australia. And also you can see plasma in the sun. That's what I just mentioned. No? So here is a picture of the what is that? Four states of matter. Here. Not so clear. The picture is not so clear, class. So here are examples of plasma: solar nebula, solar corona, lightning, flames, aurora borealis, um, inertial fusion of molecules in the phase continuity, solar core, magnetic fusion reactor, and the likes. We have here some cold plasma pen, which you can mostly see in some sci-fi movies. Which you can, I don't know if you have seen plasma pen, but they can be seen in some sci-fi movies class. So a while ago, I asked you what is the fourth, the fifth, and the sixth state of matter. Have you searched it already in your respective uh, gadgets there? I know you have another gadget. So what is the fourth, the fifth state of matter? The fifth state of matter class is having an acronym BEC, BEC. You can search this further in the internet, but I will give you the name. The name there is Bose-Einstein condensate, BEC. Again, the name is Bose-Einstein condensate. With the spelling of this, I leave it to you to search for it. And then write that in your module because there's a question of what is the fifth state of matter. The sixth state of matter is fermionic condensate. Fermionic condensate. With the spelling of fermionic condensate, just take it on the spelling of fermin. Then add ionic, fermionic condensate. That's the sixth state of matter. Okay. What does plasma pen do? Let's try to search that one. Actually, I just found out uh, that one from my research on the PowerPoint. So let's try to search that one. Plasma pen is the world's most advanced non-invasive skin lifting, skin tightening, and rejuvenation device used to treat wrinkles, skin tags, and sagging skin. Skin treatment can be of different procedures. One of these is the use of a plasma pen. So probably when you are in your uh, dual citizenship stage, senior citizen, you can try to have the plasma pen treatment to remove your wrinkles, to remove your um, black hair, the sagging skin that you will have in your old agedness. You can search further the information of plasma pen in the internet for the other use of it class. I think this is, according to the internet here, according to the source, it uses a high frequency electric charges discharge to murag pakurintihan ng imong face to rejuvenate your face, no? To give probably it's to enliven the dead cells or to kill, to remove the dead cells that is located in your integumentary system. Any other questions?
What is the other Aurora Ganeser?
Aurora australis,
And the
uh,
other one?
borealis, Borealis.
Thank you, sir.
Oh. It can be seen as a constellation as well, class. Aurora borealis is also a constellation. So as with Aurora australis. We can see Aurora borealis somewhere in the North Pole, Aurora australis in the South Pole. What else? Most of the terminologies that is found in your module class are um, are the ones that are italized, which are not, I believe this is not new to you. So just patiently read your module and familiarize yourselves with the said table because most of the questions are really from this table. And from there, you get to understand the contents of what I just write here because the explanation that comes here is just the one found in your table, like almost no intermolecular. So we have here exerts pressure, we have here exerts pressure. Compressible, compressible. By Thursday, I will be expecting you to give me answers on the different activities that I have here. In activity 2, you have choices, so please have this answer. Question? Clarification? So that is all for our lesson today, class.